like the four things, the triangles, and then we had like the half circles on to the one, and then we go and watch the other, and we only pulled out two of them.
Okay, because that's when it says all solutions. Like that's when your trig functions say find all solutions.
Find all the
Okay, but it only says from 0 to 2 pi. The other one says all solutions in the whole wide world. So you had to keep going plus 2 and pi. But if they were across the pole, straight across the pole, we did plus n pi. We just had to call one plus n pi, the other plus n pi. These guys, you're going to be finding specific values. So I didn't mix those in here because this is what you need to look for. So we solved this as if it was a regular algebraic equation. X squared is equal to 4. I would say take the square root plus or minus 2. So it's the cosecant, take the square root plus or minus 2. Now if you want, you can turn it into the, you can deal with this any way you like. You can leave cosecant of x. You can build it that way. You can turn it over. You can turn this guy over. Oh, plus or minus. Okay, here's the 2. When you get down to here, you can flip it over. Do the sign of this if you like. The sign is its reciprocal. You could take the sign. You could leave it cosecant. That doesn't matter to me. What matters is that you sketch this out. You have all 4 quadrants, and then you label it correctly. So whichever way you go with this is fine. So I've got the sine or the cosecant. The sine is y over r, and the cosecant is r over y. Either way, you get the same triangle. Make sure you know those 2 triangles. You can't forget these. And the 45, 45. Obviously, you're going to see one of these on your final. So make sure you know those. When you're all 4 quadrants, label your reference angle. 30 goes into 180 6 times. So make me 6 pi over 6, 12 pi over 6, and name every angle. Guys, make sure you look to see where does this solution have to go to. 0 to 2 pi, 0 to 4 pi, whatever it has to do, just go back around again. So this is my pi over 6, and make sure you label in radians. 5 pi over 6, 7 pi over 6, 11 pi over 6. Question?
I figured out it's y over r. I was just trying to.
Y over r. This is y over r is sine. So if you're more comfortable doing sine, do the sine. Just flip it over. Take its reciprocal.
Yeah, no, it's fine. I was thinking of it as dividing the denominator into 180. That's why I got.
Oh, okay, yeah. That's just to find the reference angle.
Okay.
That's to find this reference angle. Questions on this? My advice is when you're reviewing, get all your tests together. Put your tests in order. Like, even look at your date on the test, the unit on the test. See what questions come from which test, and then you'll know what unit you're in. Rather than look through your whole entire notebook to try to figure out what page was this, where did I find one of these. Go by your test first. Chances are, you probably don't even have to go to your notes, because your tests are usually a pretty good representation of your unit. So, usually one of these you will see from your test. Or something very, very similar. So your test is a good way to review. And then if you need so, you go back to that unit and you look at a few more examples. You can always use a book if you like. You guys opted not to take a book this year. So you can always use a book for reference. You can always Google, Google something about trig equations. There's always good equations out there. From what I understand, you could probably Google the whole example and they can come up with something pretty close. Okay. All right, next one, and this one is a common one. If you struggle, take out the sign. Factor that first, and then put the sign back in. You're going to get 2 sets of factors. It's going to factor to 2x plus 1 and x minus 1. If it helps you, do that first and then put the sign back in there, if that worries you. This only has 1 set of factors. It's like normally when the 2 is on that end. So really there's just maybe 2 ways you can get this before you get it right. Build your set of factors, set them equal to 0. You've got to solve for each one. So this one, where is my sign negative? My sign is my y, down here. Build me two triangles. Again, this is a 30-degree angle. So in radians, this is 7 pi over 6, 11 pi over 6. Here my sign is 1. Remember, when sines and cosines are 1s and 0s, you have the quadrant angles, the quadrantals. Just make sure you do this. I just say x, y, cosine, sine. You could even put this in your calculator. It will give you a hint as to what it is. The zeros, it won't give you both, but the ones and the negative ones, it will give you the one you need. Okay, so find me where this goes. And again, this only went from 0 to 2 pi. We just went from 0 to 2 pi. So I've got a 90 degree where it's a 1, so only one angle for this guy. And 2 angles for the other one, just hook them all together. There's your solution. You don't even have to do a reciprocal function, which is nice.
Why don't you go through like the 2 for 7 pi over 6 and 11 pi over 6?
Sure, did you get this far? Okay, so sine is negative in what quadrants? Sine deals with the y. Always try to remember, cosine is x, xy, cosine sine. So 3 and 4, drop 2 triangles. My board's a little bit off here. So sine is y over r. So I label 1, 2. So this must be radical 3. So who's opposite? Who's that special angle triangle that has a 1, 2 radical 3? It's my 30, 60, 90. So this is a 30-degree angle. This is where we take 30 goes into 180. 6 times. So this is 6 pi over 6. This is doubled, 12 pi over 6. If you have to do it in degrees first, do it in degrees and then convert both of them. But it's easy like to find this pattern. So as you come around and you stop right here, this goes past the 6, 7 pi over 6. This stops short of the 12, 11 pi over 6. Questions at all? This is like the extent that you'll see, but you will see one. So mark that page with a little star because you will see one. Okay, let's see what's in number 5. All right, transformations I took out. My computer's a little bit messed up here. If I can move this tab. Hang on. Okay, something's really messed up here, but we'll do the best we can. Okay, first one, the word, my word and the word on the computer is off, so sometimes my writing doesn't show up where it's supposed to. I'll just make sure this is kind of where it's supposed to be. Okay, how did I know this is a parabola? 1 squared. So that's what I care about. So I see y squared. So I know it's going to open sideways. Left is negative, right is positive. So start like this. Don't forget the 4p. I put these all on your formula sheets right now. So make sure you reference your formula sheet. If you find that you need to look something up, put a box around it so that you say, oh, I need to remember this.
Wait, are we getting this sheet for the final? This formula sheet?
I might give you a formula sheet, but not like the whole thing with the rest of the packet with the words in it. I might give you the formula sheet.
Yes.
Okay, so identify this. You want to get the y by itself. This is the only one you complete the square. It's the only one that has a square. So get these guys over here. Take the middle term, take half, square it, make sure you put it on both sides. Make sure that x only has a coefficient of 1. Factor out that -8. That's your 4p. This is your 4p. Okay, so now you know it's opening left. You know your vertex, the h always goes with the x. No matter what side it's on, the k goes with the y. And they both come out the opposite way. They're in parentheses. So get your vertex. Now give me a sketch. Now, the intercepts, don't forget your intercepts. On the parabola, you need your intercepts. How wide should I make this thing? Especially when it's close to where the origin is. You don't know, are you below it, are you above it, are you the left, the right? So get an intercept before you sketch it. Intercept, set y equal to 0. If you set y equal to 0, go right back to the original one and solve for x. Makes life easy. If you're going to set x equal, God bless you, x equal to 0, go here. Obviously, this is not going to have any because it's negative. So as soon as you take the square root, you say, no real y-intercepts. Good? Yes?
Why on the bottom did you put for the focus -2 and
This might be coming from the one below it. I think that's from the next one. I think something happened. This is here? I don't know where this came from. Oh, this is the vertex. Okay, there's the vertex. Yeah, here it is. Thank you.
Oh, okay.
So to get the directrix, that's what I did. I moved some of the next one because it was sitting over it. I didn't know if I moved it or not. But this is what Lane got it exactly. I just took the vertex and I added and subtracted 2.
How should you know the direction?
Because we took the center, we took the vertex point, and then you have to move 2. You have to move 2 over. So if I'm moving 2 this way, I add 2 just to the x and I subtract 2 to the x. Remember, directrix is a line. So all you need is the x value, the x equals. The focus is a point. God bless you. Okay? I think this next one's a little bit messed up. So we know this is an ellipse. It's a little bit out of whack here. How do I know this is an ellipse? 2 squares and they're the same sign. They're the same sign. So even if I divide it by something, they're going to stay the same sign and they can't both be negative. So this guy is an ellipse and their coefficients are different. So this guy is an ellipse. So set up your x's together, set up your y's together, and complete the square. I really don't know what happened here. It just kind of got like written on top of each other. So did you complete the square? You got to take the 4 out. Take out the 4. And complete the square. Well, I'll leave this blank. Okay, so when you complete the square, take half of this, x minus 1. When you square it, you get a 1, but you got to take the 4 out of here. So add 4. Complete this square. This is a 4, this is a 4. This becomes, that's a plus 4. That becomes 16. So when I do this and I divide everybody by 16, this one becomes a 4. Now, what's the rule? Who's the major axis? The y. Why is it the y? Because it's the bigger one. On a plus, it doesn't matter what direction we add in, what order we add in. So therefore, the larger number is the major axis. So our y is the major. And as soon as you graph it, you'll see it. It's going to go like this. So this is my a squared. This is my b squared. And don't forget to find your c. Your a squared minus b squared because you want the foci to sit inside. So the rest should almost be easy to see. I don't know where this is all coming from. The vertices are 1, 2, and 1, -6. Thank you. Okay, what's the center? What's the center? 1, -2. Okay, here's your center. You should be able to find this. What's A? Square root of 16, 4. What's B? Square root of 4. And then if I do my other one, C turns out to be 2 radical 3. Now, you should be able to find these. Your major axis is your Y. This is your vertex point. So take your center. You're only moving the Y right now. To go up here, my X stays the same. I take -2 and I add and subtract 4. So I get, if I subtract 4, if I add 4, I get a 2. If I subtract 4, I get a -6. You're right here. Add 4, subtract 4.
Wait, what is it? I thought it would be 2. No, I don't get how you got 1.
Oh, come on. B comes from here, Amanda. B comes from here. B squared. What's B squared? B squared is 4. What's the square root of 4?
Wait.
Guys, did anybody look this up last night?
Yeah.
So we got this so far. Let me rewrite this over here. Do you have this?
Oh, so A is always just the bigger ones? I thought it was under
A, in this case, is the larger one. It's the larger one because we just went over this. It's the larger one because it doesn't matter what order you add it. So this is going to be my A squared. This is going to be my B squared. What's the square root of 16? 4. What's the square root of B of 4? 2. C is C squared equals A squared minus B squared. Because your foci have to come inside your ellipse. Know how to do this.
She said divide by 16. So she got the
Got to be equal to 1. We have the equation on your formula sheet right in front of you. Okay. Hopefully the next one goes a little easier. This one came out a little bit better. I actually can't because it won't go past it won't go any further down than this. So again, how do I know this is a hyperbola this time? Because there's a minus. Not just because they're negative, because they're both different signs. One has to be a positive, one has to be a negative. And I could divide by a negative, which I do in this case, and end up switching them around. That's fine. So I complete my square. Get your x's hooked together, get your y's hooked together. The y has nothing to complete. So if you're more comfortable saying y plus 0 squared, put the 0 in there. So complete the square. Don't forget to go like this and bring it back out. Now, it's equal to -12. I need it equal to 1. So I need to divide every term by -12. That forces these two signs to change. So rewrite it so that the x comes second. The y is first because that becomes positive. A negative divided by a negative is a positive. And my positive divided by a negative is a negative. So right now we look like this. Y squared over 4 minus x minus 1 squared over 3 equals 1. Is everybody up to that?
Yeah.
So where are the asymptotes? Wouldn't it be 2 over radical 3 instead of radical 3?
Wouldn't it be 2 over radical 3? Yes. It would be. 2 over radical 3. Okay, so let's just hit this one for a second. What's A? A is 2. It matters which one comes first on the subtract. So A has to come first on this guy. So square root of 4, 2. What's B? Square root of 3. It's the best we could do to it. And C is going to be A squared plus B squared because this time you want the foci to come outside of it. So this is going to be radical 7. From there, remember, whoever's first, that's your transverse axis. That's the guy that's going to have the parabolas drawn. And don't forget to draw the parabolas. This will give you a box. You don't need a co-vertice per se, but you need to mark it off. When you find your asymptotes, you can do right here. You can go up this way, over that way, or say change in y over change in x. So you're changing y, just come underneath your y, take the square root is 2, underneath your x, take the square root, just leave it, you don't have to rationalize, and this is your slope. So take your y guy, which there is none, plus or minus 2 over radical 3, and just leave your x like this. You don't have to distribute. The only thing you would have to do is like, this is a y plus 2. The only thing you would have to do is do a minus 2 to the other side. Make sure you just get y equal. But take whatever's in your parentheses and leave those there. You don't have to distribute this guy. Okay? The rest should fall together. Good? I can tell you there are a couple where you have to complete the squares on these, and for some odd reason, they just ask like the vertices. There's a couple multiple choice. There's a vertices one. There's a couple multiple choices.
Everything else is like weird, but this is.
These are not so bad. If you just kind of reason them out, if you step back and make them make sense, they do make sense. You can try to remember on an add, it doesn't matter which way you add. So make the bigger number A. On a subtract, it matters which way you subtract. So the first number is your A. As long as you get that straight, everything else falls into place. Because everything else pretty much works the same. Co-vertices, really, we don't have them. They don't exist, but we do need them here to make this box. Just remember you need them to make the box. The box is there so that you can throw your asymptotes through the corners there, and that's your guideline to make this. There's no x and y intercept. We don't need it because we have a guideline here. We needed your x and y intercept on your parabola. Don't forget to do it there. Good? Okay, so path 1 and 2, a circle. How do you know it's a circle?
There's two squares and they're both the same thing.
Good, there's two squares, there's a plus in between them, and they both have the same coefficient. So no matter what I divide by, they're going to come out to be a circle. So just group your x's, group your y's, complete your square. It's nice because you don't have to factor anything out. Remember to move your 3 over. Guys, one of the biggest mistakes I see is forgetting to take the opposite. You're in a roll here and you always think that that has to be positive. Remember to take the opposite. So complete the square. And add them here. Okay, take half, square it, take half, square it, and add them together. What do you get, 7? 7. Okay. If you want to leave me your circle just like that, that's fine. If you divided by 7 and left it as an ellipse, I'm fine with that. Either way you go is fine.
So what do we have to find for it?
So basically, you have to find on a circle, you only need to know your center. So what's your center? 3, -1. And what's your radius?
7.
Radical 7. This is r squared. Well,
It just says find the standard form.
find the standard form, then that's all you have to do.
So we only need those two things.
That's it. Well, because on a circle, what do you need to graph your circle? You need a center, 3, -1, and you just need to go like this. If you left it as an ellipse and divided everything by 7, it's not incorrect. An ellipse, a circle is a special kind of ellipse.